All right, so here's our unit circle. And notice how all of your coordinates are square root of 3 over 2, 1 over 2, or square root of 2 over 2, no matter where you are as far as your basic uh, unit circle coordinates. Of course, there are other things that are on the circle, but we're talking about the familiar angles, the reference angles, the coordinates that are the special angles, 30, 60, and 45 degrees. And then also when you look at 0, 90 degrees, 180 degrees, and 270 degrees, those will either be 0 or 1. And then, so this is when you apply your signs to your quadrants. In your first quadrant, see, oh, can everybody see the image? Because I see one person, I see one, okay, some people can see it, some people cannot. So all I'm doing right now is looking at the unit circle file that I sent you guys. So if you cannot see it, you can always pull that up. All right. Let me see. Okay. All right. So got enough people saying they can see it. So if you cannot see it, you can always pull that up. It's in Canvas, and I sent it to you in the email. So notice how when you look at square root, not square root, when you look at pi over 6, pi over 4, pi over 3, those are your basic angles that we're looking to deal with. Square root of 3 over 2, 1 over 2, square root of 2 over 2. And then when you look at going to the left into the second quadrant, the reflection of pi over 3 is going to be 2 pi over 3. See how you have 1/2 as your first coordinate, first part of your coordinate, square root of 3 over 2 is your second part of your coordinate. But 1/2 is negative, that's because you're in the second quadrant. And then same thing happens with 3 pi over 4, referencing pi over 4. 5 pi over 6 will reference pi over 6. And so that relationship will happen throughout all of your quadrants, wherein square root of 3 over 2, 1/2, and square root of 2 over 2 are the only values that you're looking at as far as your reference angles are concerned. And then it's all basically dependent upon, your signs are basically dependent upon what quadrant you're in. So that's what I was trying to get to when we were looking at our reference angles. I just didn't have the unit circle up for you guys to look at. Questions on your unit circle and how it's set up before we move off of it and go to 5.4. All right. So if you have any questions, as always, make sure you you ask or shoot me an email and I'll answer them accordingly. So when we look at 5.4, go share. Excuse me. All right, so if t is a real number and p is the point on the unit circle that corresponds to t, then sine of t is y, cosine of t is x, tan is y over x, and then the other three. Oh, I put sine right there. Sorry about that. That should be secant. Cosecant, secant, and cotangent are the inverses. And so the key to this versus what we dealt with up to this point is that P is the point on the unit circle. And that didn't have to occur in the other ones.
Could you scroll back up so I could see the top there?
That part?
No, all the way up a little higher. Thank you.
Mm-hmm. All right, so it says T is a real number equal to the length of the intercepted arc of an angle that measures T radians. And P is going to be the coordinates negative 1/2 square root of 3 over 2, which is a point on the unit circle that corresponds to T. Find the trig functions at T. So basically, they're just asking you to apply the concept that we just mentioned. Sine of T is just Y, so that should be square root of 3 over 2. Cosine T is X, negative 1/2. Tan T is Y over X, so that's square root of 3 over 2 divided by negative 1 over 2. So if you had to deal with this without dealing with the familiars, you would set it up this way or look at it this way, even if you don't set it up this way. Wherein, as I mentioned before, this set up vertically, so that division sign is the same thing as this one, set up horizontally. And whenever you're dividing by a fraction, you multiply by the reciprocal. So that's 2 over 1. 2's cancel. Answer is negative 3 square root of 3. So cosecant is the inverse of the square root of sine. So that's square root of 3 over 2. So that would be 2 over the square root of 3. Need to rationalize. So secant is the inverse of cosine. So you're just going to flip cosine. So be negative 2. And cotangent for tan, is that a negative part of your answer? Let me go back, see if I left off a negative. Is it important to memorize the value of sine, cosine? Okay, so first question was, is it important to memorize the values of sine, cosine, and tan? Only reason it wouldn't be important is if you didn't have that. I mean, if you didn't have a test that was forcing you to do it by memorization. Outside of that, you can always have your unit circle to reference. As long as you have that reference, then you're good to go. But you should at least be familiar with them. Now going to calculus, I cannot guarantee that your professor will let you use the unit circle. So looking ahead, it would be to your benefit to try to commit those in memory. But I know in this class, especially with the current setup, there's really no way for me to enforce not using the unit circle as a reference. So it just depends on what what lies in your future, as far as actually having to memorize those relationships. I would say it would be to your benefit to memorize as much as possible when it comes to them, because it would help you. You're going to cut back on time when it comes to referencing your angles. And then somebody asked me about for tan, is that a negative or part of your answer box? For tan, it should be a negative right here. Should be a negative. All right, so let's finish it off with cotangent. That should be x over y. And really what we can do is just flip or invert cotangent. I mean, not invert cotangent, invert tangent to calculate cotangent. So that'll be 1 over, or negative 1 over square root of 3. So now we can rationalize this. And that would be negative 3 over, negative square root of 3 over 3. All right. Questions before we look at the next one?
I'm confused for the cotangent.
Mm-hmm.
You got -1 over the square root of 3. I'm confused where you got that from.
It goes back to tangent. So we flip tangent. And so, this right here would just be negative square root of 3 over 1. And so we flipped it.
Oh, you just took the final. Okay.
Yep, yep. So instead of starting right here and have to go through the work, it's the same thing right here.
Okay.
Mhm. Flip the final answer for 10. Yep, yep. You can flip that final answer for 10. Yep. It's the same thing. So, Oh, so you say you got a different answer when you started from the beginning? I mean, like just doing the work? I can show you how it should work out. So we're talking about x, I think it was -1/2. Oh, okay, great, great, great. All right, so she got it. All right, so let's look at the next one. Find values. So find the values of the trig functions at t equal to pi over 2. So here they gave a diagram, but if you can remember, at least out of your unit circle, remember your coordinates here, 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 and here. Remember we said this is 90 degrees, which is pi over 2. This is 0, which is also 360, which is 2 pi. This is 270, which is also 3 pi over 2. And this is 180, which is also pi. So the coordinates here is 0, 0. Coordinates up here is 0, 1. Over here, I went to the left 1. Now 0, and I made a mistake and wrote 0, 0 right here. Sorry about that. Should be 1, 0. And then here, 0, -1. All right. So when we're looking at pi over 2, that's the same thing as 90 degrees, which means that we know x is 1, y is 0. And why am I writing this stuff backwards? X is 0, y is 1. So we already know what t is. They gave it to us as pi over 2, so we can write sine of pi over 2. So that's going to be 1. Cosine of pi over 2 is 0. Tan of pi over 2 is y over x, which means that's undefined. Cosecant is 1 over 1, which is just 1. Secant, 1 over 0, which is undefined. And cotangent. 0 over 1, which is 0. All right. All right. So domain and range, they mentioned this right now, but we're going to touch on it more in sections coming up. They don't really go into detail about using it in right now. I guess they're just referencing it, so it won't be the first time that you see it when we actually use it. But your domain and range of your sine and cosine functions. Domain is from negative infinity to infinity. In other words, you can plug anything into sine and cosine, but what you're going to get out are values between -1 and 1 inclusive. So your sine curve and cosine curve, they look like this wave right here. And the highest it will go is +1, the lowest it will go is -1. So that's what we're talking about there. All right, so your even functions, only two, cosine and secant. When you apply the cosine to a negative value, it's the same, or you get the same values if you apply it to a positive value. Same thing with secant. And then with your odd functions, sine, tangent, cosecant, and cotangent, when you apply them to a negative value, it's the same thing as pulling the negative to the outside and applying it to the positive value. All right. Also, going back to the usage of your unit circle, it would be to your benefit to not depend solely on throwing, let's say, tangent of pi over 6 into the calculator because you'll get a run on decimal. So you want to make sure that you can give the exact value because that is what my math lab will want. That is what I will want on a test and so on. I know when I was in school, I remember how the decimal value looked. So that was my sheet around because we weren't allowed to use any help. So not even the unit circle. So whenever we had access to the calculator, I would just memorize how the decimal value would look. So, so that's one way of doing it. But just throwing it out there, make sure you know how to get the exact value. So when we look at using these odd and even relationships, and that's what it says in the directions. It says find the exact value. So we have cosine of negative 45 degrees. Well, since cosine is even, cosine of negative 45 degrees is the same thing as cosine of 45 degrees. And cosine of 45 degrees is the square root of 2 over 2. All right. Tan is odd, so I can bring this negative to the outside and then apply tan to pi over 3. I think that was the one we did earlier. And that should be negative square root of 3. So that negative sign is the same thing as this negative sign, which is this negative sign. So. Questions, questions, questions. I guess one more. Look at it. I did sine of negative 60 degrees. So once again, that's odd. So I can bring the negative to the outside. And sine of 60 should be square root of 3 over 2. And that should be negative square root of 3 over 2. Make sure 60, yeah. Okay. All right, so periodic functions. Periodic means the behavior of the function repeats infinitely. A function f is periodic if there exists a positive number p such that f of t plus p is equal to f of t. And we're going to use that relationship shortly for all t in the domain. All right, so the smallest positive number p for which f is periodic is the period of f. I know it look like period off. So it should be period of f. So basically, when your graph starts to repeat again, that's when your period stops. So the period for that function stops. I'm going to put periodic properties. That should be right. Okay. So all right. right, let me see. So when we look at our periodic properties, sine, cosine, cosecant, and secant have periods of 2 pi. So in other words, after 2 pi, it repeats the same behavior, the same cycle. Tangent and cotangent have periods of pi. So after pi, after 180 degrees, it repeats the same cycle. All right, so we want to find the exact value of cosine 420 degrees. So we know it's larger than 360. So what you would do is subtract 360 from it as many times as it takes to bring it under 360 to see what the period would be and what t would be. So if we were to minus 360 from this, we would see we have 60 left. So I can rewrite this as cosine 60 degrees plus 360 degrees. 360 is the same as pi. So that means I'm left with cosine of 60 degrees according to our relationship. And cosine of 60 degrees is 1/2. For the next one, sine of 9 pi over 4, same thing except we're dealing with radians. So we're subtracting 2 pi. 2 pi with the denominator of 4 is going to be 8 pi over 4. So we subtract 8 pi over 4 from 9 pi over 4. That should be pi over 4. So sine pi over 4 is what we have now. Sine pi over 4 is the same thing as square root of 2 over 2. Questions on that? Gotta check something real quick. Okay, got inverse trees. Okay, so that being said, looking at my math lab, and I was seeing that was assigned. You have graphs, which is 5, 5, and 5, 6. Excuse me, I'm sorry. Allergies kicking in, messing me up. So that was 5, 4. Next assignments you have are 5, 5, and 5, 6. And when it comes to graphs, normally I leave that assignment in there because get you guys familiar with the graphs and graphing. Um, Not asking you guys to go buy a graphing calculator. You can always use a graphing tool, free graphing tools that come along with, not come along, but something you can download to your phone or use as far as a website is concerned. If you type in graphing calculators, now it would be beneficial to you to have your own, but if by some chance you don't want to mess with that, then you can always Google graphing calculator and or graphing tools, and they will help you with that. So they are not. I'm pretty sure when you go in there, let me look real quick. They aren't asking you to graph them. They're asking you to identify what is the proper graph. So if you need help with putting or inputting any type of function into a calculator, make sure you get with me and let me know so I can help you out with that. But that's the main thing for those two sections, getting familiar with those functions and their graphs and identifying those graphs. So I won't spend time on that unless you guys have questions once you get in there. So with that being said, when we come back on next class, we will get into, as far as lecture is concerned, 5, 7, and looking at our inverse trig functions and how to solve those. So before we close out, questions on anything? Make sure we good.
I've got none.
Okay, you say you got none. I think you said you got and then then cut out. You say you got none. All right, cool.
No, sorry about that. Yeah.
I know you good. All right, so we'll close out right here because, like I said, at this point that would actually be 3 sections because of those 2 graphing sections. So I won't throw anything else on top of you. So try them out, see if you get stuck. If you have any questions, you can always bring them to class and we can go over them, before we go into a new section. I'm down for that as well. But outside of that, you guys have a good one. I'll see you in next class. We only have 2 more sections left before we're done with this chapter. So make sure you stay on top of this stuff so you don't, get too far behind if, you don't want the stuff to pile up on top of you. Outside of that, I will see you guys on next class. You guys have a good one. Thank you. Appreciate you.